In this video, we are going to talk about reflections. So this is the second type of transformation that we're learning this year. For your records, this is page 122 in our binders. We know from a couple of days ago that reflection just means to flip over an axis. I underline FL in reflection. That reminds me that this is just a flip because flip starts with FL. In a reflection, every point must be the same distance from the line of reflection on both sides of that line. To reflect something over a line, first we're going to count the distance to the line of reflection. Then we keep counting, so we count again, the same distance on the opposite side of that line. Reflections preserve. Remember that means, I think I spelled that wrong. Nope, okay. Preserve just means to keep or to save. Reflections preserve congruence. Hopefully we remember from yesterday that means that the figure is the same shape and size. This also means, though, that the angle measures are the same. You guys, again, remember all the time that the side lengths are the same in congruent shapes. Sometimes we forget about the angle measures. Reflections do not always preserve orientation. That means that they won't always face the same way. Won't always face the same way. And I want to make a note that if I see a minus sign in front of something as a variable, that doesn't necessarily mean it's negative. It just means that it's opposite. And the opposite of a number just means to change the sign. You'll remember a couple days ago in the vocabulary we wrote that we're going to change the sign of one of the coordinates. We're going to use that. We're going to use this negative sign to do so. We just need to make sure that we know this minus symbol doesn't really mean it's always negative. It just means we're going to change the sign. Here we're going to just write out the general rule for reflections. If we are reflecting something over the x-axis, we start with our normal ordered pair, x comma y. We're transforming this with a reflection, so I'll draw an arrow. We're reflecting over the x-axis, so the x value stays the same. The one coordinate that changes signs is y. Since I'm changing that sign, I want it to be opposite, so I'm going to use a minus sign in front of the y. This says x and opposite y. So I'm going to make a little note here. Negative y means to change the sign on y. Of the y value. Now when I flip something or reflect something over the y-axis, my general algebraic rule, x comma y, transforms by a reflection to, I'm going over the y-axis, so the y value will stay the same, meaning the x value is the one that gets the sign change. Opposites of x, comma y. And again, I'm going to make that same note here with the x value. Negative x just means to change the sign of the x value. Okay. This might not make a whole lot of sense right now. In a moment, when we look at some examples, this will become a little more clear to us. So we'll look at two examples on the front page. Here I've got pre-image coordinates A, B, and C. I'm going to start by plotting A, B, and C on this graph here below. A is located at -3, 5, so -3, 5. 5. I'll call that A. B is at -1, 2. -1, 2. Here is B. And C is at -4, 2. -1, 2, 3, 4, up 2 is where I have C. I wrote B prime there, and I'm not really sure why. That should just say B. I'm going to connect the dots to make my triangle. Okay. Now this is asking me now to reflect over the x-axis. So up above in that paragraph, to make a reflection, I need to count to my line of reflection. My line of reflection is the x-axis. That is this line right here. So I need to count how far each point is away from that line, and then keep counting on the opposite side of that line the same exact distance. So if I start at B, B is 1, 2 away from the line. So I'm going to keep counting 2 away from the line on the other side, and that's where the new B is, or B prime. We'll do the same thing for A. A is 1, 2, 3, 4, 5 away from the line of reflection. So I keep counting 5 from that line on the other side to find the new A. 1, 2, 3, 4, 5. Here is the new A, or A prime. C is 1, 2 away from the line of reflection. So I count 2 away from the line on the opposite side. That's where I find the new C. Now I've got the same triangle, it's just reflected, going, now it's pointing down instead of pointing up. Let's talk about the image coordinates here. So I want to look at the coordinates for A prime. A prime is right here. That is located at -3, -5. -3, -5. B prime is located right here. Its coordinates are -1, -2. B prime is at -1, -2. And C prime is located at -4, -2. This question asks, how are the x values changing? So if I look at my x values, that's the first number. I started with -3, and I ended at -3. For B, I started at -1, and I ended in B prime at -1. I started at -4 with C, and I ended at -4 in C prime. So the x coordinates didn't change at all. They stayed the same. How did each y coordinate change? I started with 5 in A, and A prime's y value is -5. So I just changed the sign from 5 to -5. Here I had in point B a y value of 2. In B prime, the y value is -2. We just changed the sign. We went from +2 to -2. And point C, the y value is 2, and in C prime, the y value is -2. Again, you can see we just changed the sign. So instead of writing change the sign, I'm going to write the y value became opposite. So now I want to write the rule for this. To write the rule, I'll start out by writing a normal ordered pair, x comma y, and I'm going to transform this using a reflection. And here's my new ordered pair. The x values stayed the same, so x didn't change, which means this is going to stay in x. The y values became opposite. Their sign just changed. To write opposite y, you write a little minus sign in front of y. That doesn't say -y, that says opposite y. So this says keep x the same and change the sign of y, which is exactly what we did in each of those coordinates. Let's go ahead and look at the next example. We have the same exact triangle, the same pre-image coordinates. A is at -3, 5. Label that A. B is at -1, 2. We'll label that B. And C is at -4, 2. We'll label that C. And here is my triangle. Okay. Now I want to reflect this triangle over the y-axis. Let's take a look at where the y-axis is. Here's y. That's the up and down axis. So now when I'm reflecting, I'm counting how far is each point, the distance of each point to the red line here, the y-axis. A is 1, 2, 3 away. So I need to be 3 away on the opposite side of that line. 1, 2, 3. That's the new A, or A prime. B is 1 away from the line. So on the other side of the line, B prime has to be just 1 away. Right here is B prime. To go from C to C prime, we're going to count how far are we from the line of reflection, the y-axis. 1, 2, 3, 4. So I need to count 4 more on the other side of the line to find C prime. 1, 2, 3, 4. Now C prime here is the same distance to the red line as C was, just on the other side. And here is my triangle, now reflected over the y-axis. Let's look at the image coordinates now. I'll need A prime. A prime is now located at +3, +5. B prime is now located, B prime is at 1, 2. 1, 2. And C prime is at 4, 2. Let's look to see how my x values changed. So we start with -3 x value in A, and A prime's x value should have been +3, and I said it was +5. You see that? This is A, that is at 1, 2, 3. I guess that looks like a 5 to me. Those numbers are a little hard to read, and I clearly didn't count. So we start at -3 for the A value, the x value in point A, and we end up at a +3 for A prime's x value. So we just changed the sign there. B's x value is -1. B prime's x value is +1. Again, we're just changing the sign from negative now to positive. And C prime's x value was -4. Sorry, C's x value was -4, and C prime's x value was +4. Again, we're changing the sign from a negative number to its positive number. So how did the x coordinates change? If it was negative, it became positive. So we just changed the sign, or got the opposite of the number. We took the opposite of x. The y values, the y value in A is 5. The y value in A prime is also 5. That stayed the same. The y value in B is 5. The y value in B prime is, the y value in B is 2. The y value in B prime is also 2. That stayed the same. The y value in C is 2. And the y value in C prime is 2. That again stayed the same. So each of my y values stayed the same. Now I'm going to write the rule for that transformation. So we start with a normal ordered pair x, y. And I want to know how am I going to transform it. I'm going to write an algebraic rule for the transformation. This is the pre-image. How do I write the image? all of my x values are going to be opposite. To write opposite x, we write a minus sign and an x because this says the opposite of x, comma, the y value stayed the same, so I'm just going to have a normal y exactly like I did before. That's really all there is to reflections. I'm gonna extend the video a little bit more to just go over some more examples. If this makes sense to you at this point, you can probably stop watching and get started on the assignment or apply this knowledge to however you're doing that. Oh, the pen's bleeding through. Oh no. Okay. I'm using this pen. Okay, here I've got preimage coordinates 6, -3, 2, 0, and 0, -5. So I'm plotting my points at 1, 2, 3, 4, 5, 6, -3. There is point A. 2, 0. 2, 0 is point B. And C is at 0, -5. 1, 2, 3, 4, 5. Okay, so here is my triangle. That's my preimage. I need to reflect this over the x-axis. The x-axis is this side-to-side axis here, the x-axis. So to reflect each ordered pair, to reflect this triangle, I'm going to reflect each point, each vertex of the triangle over the red line. When I reflect A over the red line, I'm counting the distance from A to the red line. That's 1, 2, 3. So I need A prime to be 3 away on this side of the red line. 1, 2, 3. There is A prime. When I reflect C over the red line, C is 1, 2, 3, 4, 5 away from the axis of the x-axis. So I'm going to keep counting 5 more away from the x-axis on the other side. So C prime is at 0, 5. B, however, is on the x-axis. So I'm counting 0 to get to the red line, which means I'm counting 0 to go away from it. So B doesn't move to get to B prime. B and B prime are the same point. And now there is my image. So now that we've got the image, we can go ahead and write the image coordinates. I'll need A prime, B prime, and C prime. A prime is located at 6, +3. B prime is located at 2, 0. And C prime is located at 0, 5. This is a reflection over the x-axis, and we saw earlier that when we reflect over the x-axis, the x values stay the same, and the y values become their opposites. So why is point B the same as B prime? Because the opposite of 0 is just 0 again. 0 doesn't have an opposite, it's neutral. So B and B prime are going to be the same value here. That doesn't affect us with C because the x value is 0, which means that that's going to stay the same. So the actual, the natural number, or the whole number, -5, goes to the natural number 5. That's why C and C prime are different and B and B prime are the same. Writing the rule for the transformation, we start with x, y. An arrow to show we're transforming it. X's stay the same because I reflect over the x-axis, so the x value stays the same. And the y value then has to be opposite because in a reflection, we're going to change the sign of one of the ordered pairs. Coordinates, one of the coordinates. Now let's look at the next example here. We have preimage coordinates of -8, -4. So -8 is, that's 10, 9, 8, and then -4, 1, 2, 3, 4. There is A. B is at -3, 0, -3, 0. And C is at 0, -6. 1, 2, 3, 4, 5, and 6. There is C. So here is the pre-image triangle. And this is asking me to reflect over the y-axis. That's the up and down axis, or this line here. Now that we're reflecting over the y-axis, I want you to think about what this shape is going to look like before we actually go ahead and plot it. Okay, let's go ahead and find where B prime is going to be. So we're going to count out how far B is from the line of reflection. That's 1, 2, 3. So we need to count in that same direction on the opposite side of the line. 1, 2, 3. This is B prime then. Let's find A prime. Here's A. A is 1, 2, 3, 4, 5, 6, 7, 8 away from the axis of reflection. So we're going to keep counting 8 in that same direction. 1, 2, 3, 4, 5, 6, 7, 8. And there is A prime. Now C is on the axis of reflection, so it's 0 away from that. So C prime is going to just be on that axis still. C and C prime now are the same points. And here is my image triangle. Let's look at the image coordinates. I'm going to need a coordinate, the ordered pair for A prime. A prime is located at +8, -4. Point B prime is located at +3, 0. And C prime is located at 0, -6. We know from the front of this paper that when we reflect over the y-axis, the y value stays the same, and the x value then is opposite because one of those coordinates has to become opposite. So y is point C and C prime the same because we were on the x-axis where we had to become opposite, but the number 0 doesn't have an opposite because 0 is neutral. Writing the rule for the transformation, we'll start with x comma y, normal ordered pair. To show a transformation, we draw the arrow. X's become their opposites, so we write a -x to show that the sign of x is changing. And then the y value stays the same. In this last example, if you were in class, I had you pick whichever axis you wanted to flip over here. I would like to show you guys both the x and the y-axis, so I'll show you guys the x-axis reflection in red, and I'll show you the y-axis reflection in blue. So we'll go ahead and get started plotting those points. A is located at the origin. So that is A. B is located at 0, 4. That's B. And C is located, I plotted point B wrong. B is located at 0, 4, so that's 0 up 4. There's B. And then C is located at 3, 0. There is C. So here is my original triangle, my pre-image. When I reflect over the x-axis, that is side to side, we'll notice that A and C are on the x-axis, so those ordered pairs will be the same as what they were, 0, 0, and 3, 0. The y value can't be opposite in an x-axis reflection. In an x-axis reflection, the y value has to be opposite. But the y values can't be opposite here because the y values are 0. Now let's look at what B prime is in that x-axis reflection. That's going 1, 2, 3, 4 away from the line of reflection. So we keep counting 4 in the opposite direction. 4. There is B prime. Here is A prime and C prime. And this red triangle is the x-axis reflection. B prime is located at 0, negative 4. How did the x values change when we reflected over the x-axis? The x values stayed the same. And the y values became opposite, which we can see clearly when we look at ordered pair B, because 4 became negative 4. We can't tell that when we look at A and C, because we don't know if this is the same 0 or the opposite 0. Writing the rule for an x-axis reflection, when we reflect over the x-axis, the x value stays the same, and the y value becomes opposite. To write opposite y, we write what looks like a negative sign and a y. That just means the opposite of y, or change the sign of y. Now we'll reflect this over the y-axis. The y-axis is going up and down. You'll see A and B are on the axis, so A prime and B prime don't change ordered pairs now. Because when we reflect over the y-axis, the x values have to be opposite, but the x values of A and B are 0. And we don't have an opposite of 0, because 0 is neutral. Now when we look at C, C is 1, 2, 3 away from the axis of reflection. So we keep counting on the other side. 1, 2, 3. And there is C prime. Now when I connect my triangle, that's this right here, is the y-axis reflection. Oh, and C prime now is located at negative 3, 0. Negative 3, 0. When I reflected over the y-axis, the x values became opposite, and the y values stayed the same. When I write the rule for a y-axis reflection, the y value stays the same, but the x has to become opposite. If you've made it this far, I want to help you out with the homework a little bit. Thank you for watching. I'm going to pause this video real quick. I have a knock at the door. Bum, bum, bum. Okay. I want to go over now just a couple of the homework problems. In number 2, I just want to point out that this is a transformation. It says that this is the pre-image at 2, 3, 2, 5, and 4, 2. This is the pre-image. That means that this would be the image. And I hope it's clear that we didn't flip this triangle either way. This was a slide, which means this was a translation. So when you're writing the rule, you're going to have to use add and minus. Remember the rules for translations. look like x plus or minus a number, and then y plus or minus some number. So you're going to have to decide, how are you going from the preimage to the image? How do you go from the preimage to the image? Next, I want to look at number 7. It says to reflect the preimage across the x-axis and record the coordinates of the image below. The x-axis is the horizontal line. Notice A and B are on the horizontal line, so A prime and B prime are exactly the same as the preimage coordinates. H is 1 away from the x-axis, so we keep counting 1 on the opposite direction to get H prime. G, also 1 away, so we count 1 away on the other side of the line, that's G prime. D is 1 away, so we count 1 away on the opposite side of the line. B is on the axis, so that's where that stays. Oops. C is also 1 away from the line of reflection, so we count 1 on the other side, and there is C prime. We got D already. E prime is E is 1, 2, 3 away on the bottom side, so I need to count 3 away on the top side to find E prime. F is 1, 2, 3 away from the axis of reflection on the bottom, so I count 1, 2, 3 away from the axis of reflection, but on the top side now, and that is F prime. And then we've already plotted G prime. Now this is asking me to write the coordinates for the image. So I need coordinates for A prime. A prime is located at -4, 0. I need to know what is B prime. B prime is -1, 0. C prime is -1, +1. D prime, -2, +1. E prime, -2, 3. F prime, -3, 3. G prime, -3, 1. And H prime, -4, 1. Now look at 6 and 8. I want to remind you to read very carefully. 6 and 8 ask you to translate the image below. If I'm using the rule x minus 4, y plus 3, x goes left and right. And if I have x minus, then I'm going to the left. So this is going to be left 4 times. And y going positive is up, so this will be up 3 times. So you're taking every single point and you're moving 1, 2, 3, 4, and then up 1, 2, 3 to get to the prime coordinate. 4 times to the left, 1, 2, 3, 4, and 3 times up. That's for everything in number 6. In number 8, this is another translation. This time you're going to the left because this is a minus on the x. And the minus is on the left side of the x-axis, so you're going left 2. And instead of going up, because up is positive on the y-axis, we need to go down. That's where the negatives are. So we're going to go down 5 for our y values. So you're bringing every point left twice and down 5 to get to the prime point. Left twice and down 5. And you would keep doing that until you have all of the points plotted. If you have any further questions or concerns or comments, feel free to email me, send me a Schoology message, or drop a comment on the video.